Okay, we'll get started with the water permit form with the Department of Water Resource. We're fortunate to now have an irrigation water permit form with the DWR. This is an opportunity to hear from the department about the water permit process and provide feedback. First, we're going to hear from Andrew Nygren, the Director of the Water Appropriation Division. Then we'll have time for questions and feedback. Thank you, Andrew, for being here. Andrew has been the Director of the Water Appropriations Division for nearly 2 years. He took over for Chris Bader and has now been with the division for nearly 20 years. Thank you, Andrew.
All right, as stated, I'm the Director of Water Appropriation, named Andrew Nygren. I'm going to be going over some of the division processes associated with water permitting. I know some of you already have permits, but some of you may be looking to apply for permits, so I'll go through that process and then subsequently talk about the review process. So Water Appropriation Division, we basically administer and enforce water laws, rules, and policies to ensure sustainable water resource management and protect prior appropriators. The statutes we enforce are covered in Chapter 6104 and then in Rule Article 8903. We essentially have 4 sections. We have a water permit administration section that largely deals with the application process. And then after a permit's issued, the perfection process, beneficial use process, and cancellation process if need be. We have a groundwater management section that deals with the review of groundwater permit applications, a surface water management section that deals with the surface water review of applications for surface water sources. And then we have subsurface exploration section that's involved with our test hole drilling and groundwater observation well installation. Our responsibilities, we identify and map basically the water resources of the state, ground and surface water. We deal with the administration of water permits and applications. We provide recommendations to the director on water permits and applications. We're required to maintain a permanent water permit record. We also, through our annual use reporting program, which is handled by our water permit administration section, we monitor annual use. Additionally, we have in the past assisted municipalities and other public entities in water supply problems. So some of the processes that I'll be covering is the application process to apply for a conditional water permit application. Once that process is completing, the review process, under the assumption that it's approved, the beneficial use process, the inspection perfection process, and then the cancellation process for permits that were issued that are no longer putting water to beneficial use. So applying for a conditional water permit. First question is, do you need a water permit? If you're going to be using less than 12.5 acre feet and the contemplated use is domestic livestock or fish and wildlife, a permit's not needed. If you're going to be irrigating less than 5 acres, then a permit is not needed as well. For a temporary project that's not going to exceed 12 months, you can take the route of a temporary water permit. But if you're not satisfying any of those criteria, then a conditional water permit is required. There's basically 3 steps to the conditional water permit application process. It's submitting an application, there's a notification process, and then there's a public comment period process. A complete application is just basically the form, a project map that's prepared by a licensed surveyor that shows the withdrawal points, the location of the irrigated acreage, and if it's an impoundment, the location of the impoundment. There's an application fee that's associated with it, as described here. Now, the date that we receive that completed application, that date is marked the priority date. We're a prior appropriation state, so that priority date basically affords you the right from whatever source it establishes your priority date for the source that you're seeking to withdraw the water from. So if your application is incomplete, we're required to notify you within 30 days of any deficiencies to the application, and then you have 60 days to correct it to retain your original priority date. If it was received after 60 days, then that becomes your priority date. And after 120 days, then that application is returned and the application process would have to start all over. Assuming you receive your completed application, then that begins the notification process. The notification process requires you by statute to notify all landowners and permit holders within a 1 mile radius, and then any public use facility within a 12-mile radius. And you provide proof of that by submitting an affidavit of notice and Form 3877. Again, there's a timeline on this too. So you're supposed to complete this notification process within 60 days in order to retain your priority date. Between 60 and 120 days, that becomes your new priority date. And if the notification process isn't completed within 120 days, then the application is returned. After the notification process is complete, then we move on to public comment. And what happens there is a notice of the application is sent to the applicant for their review, and then also it's published in the county newspaper of record. It's published for 2 consecutive weeks, and there's a 30-day comment period that begins on the first date of publication. And that allows any member of the public to write in about any concerns they may have regarding the proposed appropriation. After that 30-day comment period, that essentially completes the conditional water permit application process itself. And then it moves into the review process, which is handled by the groundwater management section or the surface water management section. That application process itself is handled by the water permit administration section. So in order to grant in the review of a water permit application, the applications are reviewed in order of that priority from the system, so that's where your priority date will come into play. The staff hydrologist will draft a recommended decision to approve the permit as requested or approve a portion with the remainder being held in abeyance or denied. It may also be recommended to deny the application or defer the application pending additional data collection. In order to issue a water permit, the application must satisfy the criteria in 610406. This criteria is basically that the rights of a prior appropriator will not be unduly affected by the proposed appropriation. Your means of construction are adequate. The purpose for which you're going to be using the water is a beneficial use. Then it also satisfies the public interest. Now, as part of satisfying the public interest, the department is to consider there's 6 sub-criteria underneath that: the benefit to the applicant, the effect on economic activity, public recreation opportunities, harm to others from it, and then the actual intent and ability of the applicant to complete the appropriation. Once that RD is then sent to the applicant and parties of record, if there are any, and then there's a 30 days once they receive the recommended decision to submit comments or request an adjudicative proceeding. If an adjudicative proceeding isn't requested, but there are additional comments, the department would consider those and then issue a final decision. So this moves on to the beneficial use process if the conditional water permit is approved. So the approval of the recommendation, it results in the issuance of a conditional water permit. And a conditional water permit is a permit that authorizes the construction of works to put water to beneficial use specified in the conditional water permit by the prescribed date on the permit, which is known as the beneficial use date. Once that beneficial use date comes up, the department will send a questionnaire to the permit holder, and it's basically an update on where you are with development. If the works are developed, then we would initiate the perfection process. If not fully developed, the permit holder may request an extension of time and cite a reason for requesting an extension of time. The extension request is evaluated under North Dakota Century Code 6104. This basically specifies that good cause must be shown for not developing the proposed works. Now, in non-competitive areas, extensions would generally be granted. In competitive areas where there's a limited source of supply, the department essentially cannot grant an extension of time, and the permits are considered forfeited or canceled. Now, if the works are developed and fully developed and the works are inspected, this is completed by the Water Permit Administration section. They'll verify compliance, and then they'll also check to see if the developed works match the authorized works. They'll draft a recommendation to rectify any sort of compliance issues, say that the irrigated acreage doesn't exactly map what was originally requested, other sort of items like that, and then they'll issue a perfected water permit for the developed works. And that perfected water permit becomes your right, and it's typically recorded with the county recorder's office. Now, permits can be canceled for non-use, and statute specifies 3 or more years of successive non-use. Now, if we find that a permit is subject to cancellation, we would draft an RD for the cancellation or recommendation to cancel the permit. That recommendation is sent to the applicant or the permit holder first, along with what is called a stipulation waiver. Now, if they sign the stipulation waiver and return it, then we can issue an order canceling the permit. If that is not returned, then a notice is sent to the permit on the cancellation. The notice is published in the newspaper for 2 consecutive weeks with specifying a date with which comments must be received. And then if we receive comments, we review them and issue a final decision to cancel or not cancel the permit. If no comments are received by that specified date, then we must cancel the permit. I mentioned this during the inspection process, but there can be changes to a permit or an application at any time during the application phase itself, or if the application is pending review, or if it's been issued and there wants to be subsequent changes to it. One common change is to add a point of diversion. That would mean that, for example, the location where you initially wanted to withdraw water from a surface water source or a groundwater source isn't feasible, so you could move it to an adjacent piece of property that you would have interest in. That process, that application process for a point of diversion is exactly the same as the water permit application process that I already covered. There also is a lesser known amendment that also is processed and evaluated in the same manner as a water permit application, and that's a change in purpose of use. So for example, going from industrial to irrigation or irrigation to livestock, for example, would be an acceptable change in purpose of use. Other common changes to permits includes transfer of approved irrigated acreage. There is the ability to increase approved acreage. Rule limits that to 10% the originally approved acreage on the permit though, and increases or any sort of changes in the pumping rate or withdrawal rate from the source. So North Dakota requires that any permit holder that's using water has to submit an annual water use report. And the process for that begins in early November, where we send the first mailing to all irrigation permit holders. Our second mailing is coming up here the 1st of January here, the first week of January, and that's a second notification to all the irrigation permit holders that haven't already submitted their annual use reports, and to all the industrial and public use permits. The final notification is sent in early March, and then those forms are due by March 31st each year. We also manage temporary water permits. Temporary water permits, they're issued up for 1 year and they're considered from excess water from a system. They don't establish a water right, and they're can be subject to conditions to ensure only excess water is used. There's an application fee that's associated with those. Typically in the past, they've been used for temporary works, road construction or other temporary permits. More recently, bulk water supply for oil field use. So here's a little statistic on that. Up until 2009, we only started recording the temporary water permit applications we received starting in 98 or 99. So the average each year was 190, predominantly road construction and other sort of temporary construction projects. Since 2010, that average has jumped up to 617. As of 2025, December 8th, we've had 598 submitted. So now I'm just going to give you a brief summary of the total number of permits that we have in the state. This gives you a historical timeline on the permits that we've received based upon the priority date. So you can see certain spikes that we have seen throughout the period of record of permits being received. You can see in the late 1970s, we saw a significant increase in the number of applications. That was in the response mostly to irrigation development. Again, we saw increases in the early to mid 1990s associated with irrigation, and then we also were beginning to receive a number of rural water and municipal permits as well. And then you see that spike beginning in the late to early 2010s, late 2000s. That's associated with oil field development, largely in the West. And then you can also see the significant increase, that inflection point on the total number of conditional or of temporary water permit applications that we received beginning in 2008, 2009. So this gives you sort of the statistics of the temporary water permit applications that we've received. This is based upon data from January 1 onward. So you can see typically we get a majority of our temporary water permits applications in January, February, March. A lot of the times they're wanting to take advantage of spring flows and capture that water before it runs downstream. Whereas you can see it tapers off. And then I'll note here that it shows that we have December is incomplete here because I pulled this data as of December 8th. Moving back to water permits, this is a total summary of all the permits that we have in our database. There's 7,618. Majority of the permits by use type are for irrigation. You can see that there's 62% of the total permits that have been submitted or that we have on record are for irrigation. The majority of the permits by status are either canceled or perfected. And then you can see there's smaller percentages of the other statuses. So you can see we have 13 applications that are in processing right now, meaning they haven't completed the conditional water permit application process. And right now there's 32 permits that are under review. So this is a summary of basically the permit actions that were made from January 1 through December 8th for the Water Appropriation Division. Thus far, we've issued 106 permits for this year. Average from 2020 to 2024, if I recall, was about 50, so we doubled what our average was. Additionally, 100 permits were canceled, and then 50 permits were perfected. Additionally, not included in here, 14 applications, or 12 applications, I believe, were denied as well. So the sum, and then along with 533 temporary water permits that have been reviewed thus far. We also received 33 applications, which is below what we have received on average in the past as well. So the sum total of our permits issued, canceled, and perfected is almost 260. I summed those values this morning, and that's basically that's the most permit actions that we've taken in the last, I pulled it from 2000 onward. So it was a fairly productive year as far as issuing permits, canceling permits, and then also perfecting permits. Reese presented this earlier today, but it's our total water use from 2024. Half of it is for irrigation, and then you'll see another about 25% or so is for public use, and then the remaining is for industrial. Permitted water use, Reese already presented to this morning as well. You can see the variation in the total amount of water used. A more accurate way to somewhat present irrigation data is presented here on the next slide, where you can see the total acres reported compared to the acre feet. You can see irrigated acreage being reported is around 300,000. Even though the reported acre feet varies, and obviously that's for potentially increased efficiencies in irrigation, and then also rain offsetting the amount or offsetting the need to apply water via irrigation. So our average use as far as inches applied, you can see it's hovering around maybe the last 20 years or so, around that 9 inches per irrigated acre. So temporary water use, the majority of the water that we receive for temporary water permits and reported is for industrial water use. For bulk water supplies, that's, we're calling it industrial water depot, with other values fairly below that. So as far as data collection activities that the division's involved with, and also one of the other divisions, the atmospheric resource and data collection division, 4,400 measured sites in 2025. Our subsurface exploration group, this over the field season, we added 73 observation wells or replaced observation wells. We're wanting to replace a lot of our observations we have throughout the state that are 1.25 inch. Those would have been wells that were installed probably prior to 1985. We want to get those into 2 inch because that fits with our presence devices. The transducers do not fit down the 1.25 inch wells. We also did 10 test holes, and then the production well was actually, we got a new rig this year, so we cooperated with Game and Fish to actually install a production well at the New Missouri River boat ramp in Mandan, car bodies. So of those 4,400 sites, we have now over 600 real-time groundwater sites, 60 plus surface water sites. We continue to cooperate with the USGS on their gauges. And then the presents are actually being expanded to include more precipitation and soil moisture real-time sites as well. So Reese presented this too. This is our measured sites, and then also shows our presence observation wells and our surface water sites as well. Last summer, there was an AEM data collect that was completed in over the Central Dakota Aquifer, and then also in the southeastern portions of the state over the Miller Channel Aquifer, and then also the Cheyenne Delta Aquifer. That data was, that project was completed, and the data was delivered earlier in early spring. And then later on here, I'll present just a little glimpse of what we're working towards with leveraging this AEM data. Reese also mentioned the MAR assessment phase 2. There's sort of 2 goals with this. One is the feasibility of managed aquifer recharge, and then also these numerical models are also being used to assess the current level of appropriation, and then whether or not further appropriations can be made based upon the pending application. So there was these 3 identified. These were the ones that were ranked as the top tier, so to speak, for managed aquifer recharge possibilities. So the Wahpeton Buried Valley, which has had 40 feet of water level decline since the city of Wahpeton developed its municipal supply. It had 40 feet of decline. Those water levels are stable. It hasn't continuing to decline, but because of that 40 feet decline, there would then be 40 feet of head to potentially recharge the aquifer. Spiritwood Warwick Aquifer, that's also an aquifer used for irrigation, and it is also a major rural water and municipal supply for the cities of Devil's Lake, and then also northeastern North Dakota as well. Elk Valley Aquifer, also a major rural water supply aquifer, and also heavily involved with irrigated agriculture as well. So one of the goals with that Elk Valley one was because of the coexistence of both rural water supplies and irrigation supplies, and the fact that there's 48 deferred applications, is can these models be used then, or delivered model be used then to approve additional water out of that aquifer, and can managed aquifer recharge be used to approve additional water beyond what would be able to approved without the use of managed aquifer recharge. Those are currently underway. We're expecting completion of that likely before May. So now I'm going to touch a little bit on the review process. So I touched on the hydrologist drafting recommendations. So first I'll start with sort of the surface water process that our hydrologist would take. We do have all the staff in here if you have questions with them after this or during this irrigation forum. The exception is Bryce. Bryce is attending the Yellowstone River Compact meeting. But this is the project areas that they have. So if your application is in one of these areas, they would be being reviewed by that staff hydrologist. So basically they just give an overview of the area. That would be the hydrologic setting. So the hydrography, what basin, sub-basin, watershed, sub-watershed it's located in, what area of the state is it located in, the physiographic setting, is it located in the Coteau, is it located in a lake plain, is it located in the Badlands area. That gives you insight into how the runoff relationship is going to be. Obviously, if you're looking at a hydrograph in like the Lake Souris Plain, that's going to be different than if you're looking at a runoff hydrograph in the Badlands. There's also a climate summary. This data is actually pulled from the PRISM group. It's out of Oregon State. It basically aggregates a bunch of different climate sites from across all these different agencies and presents it into one climate data set for you. Obviously, if it's on a stream too, you're going to be looking and considering the existing water rights up and taking those into consideration downstream and upstream. The ones upstream would be taking water that would potentially limit the flow for the application, on downstream would be the ones that you'd have to protect. And then wherever that is located, we want to get an estimate of the drainage area that's going to be entering the requested withdrawal point. And for that, we'll use stream stats. So this is just from the stream stats website. It's a point and click. You can point on wherever you want to take the withdrawal point from. It'll give you the drainage area, and then it'll also give you a number of other properties that are associated with the watershed. So during the review process of this, Reese touched on the use of Python scripting. So this is the USGS stream stats site. However, when we're pulling that data, we're scripting it. We're using a Python script to pull it directly from the USGS website. So then we're not having to point and click, and it makes it a more efficient workflow process since that drainage area is automatically coming in for the review. Then obviously, as I mentioned with the criteria, we have to consider the effect on the prior appropriators and also the source. So leveraging the USGS gauging network that we're cooperatively involved with, we can generate a statistical analysis on the availability of the water requested. We can use the drainage area ratio. That's where we would look at the drainage area and compare it to the drainage area of the USGS gauge. And then we can also use tools called record extension, where if we don't necessarily have active monitoring on that, but we did at one time, because the USGS used to have more active gauging stations that were subsequently removed in the 80s and 90s. If they're nearby an existing one, we can do statistical analysis to extend the period of record for that surface water source. Also, in 2019, the USGS updated the 50% and 80% annual yield that used to be found in the North Dakota Hydrology Manual. And then also for surface water bodies, we'll estimate source volume based upon surface area and volume regression analysis. So what that looks like is on the left graph is basically showing a collection of data points that we got from the North Dakota Game and Fish, also the USGS, and then there was also a thesis that was conducted by the University of North Dakota that was looking at surface area volume relationships in sloughs in the, I want to say, the Turtle River watershed. So we use that. You can see that we generate a regression line. We have some prediction limits, and we can use that for assessing how much volume with it. Another method that's employed too is basically a water budget model for a slough, where we know what the volume is and we can get a volume surface area relationship, estimate the inputs, estimate the outputs, and then add the withdrawals from it and see what the impacts are on the slough. And then we can also use the statistics available at USGS websites. I popped up this little Missouri near Watford City, showing the mean, the different quartiles of flow. It looks like the 10% and 90% isn't showing up too well. I apologize for that. And then there's a minimum flow in there I put in there, where we'd want to be comparing the requested withdrawals to some sort of set minimum flow. Now this is a little bit different. This minimum flow is 30 CFS, which was set for the Little Missouri Scenic River Act, but it would also be applicable to any other potential source. So now moving on to the application process for groundwater permits. It's similar but different, obviously. Um, Here's a map of the project areas that are associated with all the groundwater hydrologists that we have. They're all here too, so if you have questions with them regarding an application that you may have, or if you're interested in potentially submitting an application, you could visit with them. Basil is not here right now, so if you have any questions of those, you could ask me or ask Kimberly Fisher as well. So similarly to the surface water source, where you're looking at the hydrologic setting, here we're looking at the hydrogeologic setting. That basically involves describing the geologic and physiographic setting. So this largely is taken from a number of the county groundwater studies that were completed in the 1960s through the 1980s, then also the subsequent work that had been done in the aquifers under the review of any sort of applications that have been approved in that area. Similarly, a climate summary from the prison group. Then again, you'd be looking at the existing water rate summary from the groundwater source. We'd also be looking at a summary of reported use, and then looking at historical aquifer water levels using our presence, which has been valuable in assessing aquifer water level changes on a seasonal and then longer time scales as well. So here's just an example I pulled up. This is just basically if you're heading east and you get to the Dawson exit, if you look north a mile, that's where the A is at. And then if you see where the southeast or the A prime is, that's about 6 miles south on Highway 3, I believe, as you head towards Napoleon. So the yellow is basically showing where the sand and gravel deposits are. The blue is where you have clay, till. And in this area, this is in Kidder County area, it's not uncommon for there to be interembedded sand. And this is basically a buried valley that's overlaying the bedrock, which in that area is pure shale. So this is just an interpretation that I have based upon the driller's logs that we have, both the state and private test hole drilling. So I mentioned earlier that this past 2024, there was an AEM data collect over that, and then we got that data here in 2025. So we can use that AEM data to basically take a hydrogeologic cross-section like this and then create an AEM cross-section. AEM cross-sections are basically calculating, or they're giving us back a resistivity value for the encountered sediments. So the results of that is something that looks like this. So all of those white dots that you see there, those are the AEM data points. And then the resistivity values, there's a resistivity value associated with each of those white dots that you see there. And then along the right-hand side there, I have a scale there on the resistivity, and you can see that sands have higher resistivity, and then the clays, notably the pure shale, has a significantly lower resistivity. So long-term goals, when I was thinking about how we can leverage this data, is that we have a number of we have significant test hole drilling information, especially in Kidder County, but we have it in other sorts of the other parts of the state too, and we have done these AEM data collects. So we can take all these resistivity values. They're going to be associated with a known lithologic point, and then we can use that to generate potentially a regression model then to more accurately map the subsurface lithologies in the areas where we've collected AEM cross-section, or where we have AEM data. And then long term then, that gives us insight into some of the other aquifer properties that I'll be covering here a little bit later on. So I also touched on climate. So this is some of the information that we can pull from the PRISM climate group. This is from the same area, Central Dakota Aquifer area, for continuity's sake here. The graph on top is presenting the annual precipitation broken down into the winter and summer months, where winter is being defined as October through March, and then April through September are being defined as the summer months. And the information that they also present on that PRISM climate group, you can also estimate basically a reference crop evapotranspiration. This is using the modified Hargreaves equation, which is basically just taking Tmin, Tmax throughout the day, and then the mean temperature, and then dependent upon where you are, um, it also varies on the amount of radiation that you're getting based upon your latitude. But there's simple inputs for it, so you can get a quick estimate on potential crop. You can get a quick estimate on reference crop evapotranspiration, and then net evapotranspiration, which would be the amount of water, which would be the net evaporative transportation minus the precipitation. And we also would look at annual water use. So here I just pulled Central Dakota Aquifer water use from 2000 to 2024. Irrigated acreage is in the orange color, and the blue is the reported acre feet. You can see an increasing trend in the amount of irrigated acreage in Central Dakota Aquifer as more permits have been issued, and then you can also see the variation in water use. Now, when we're considering a new application, say we're considering a new application in the Central Dakota Aquifer, I've got that 8.7 average inches. So when we're considering a new application, we're not necessarily considering the use of 18 inches of water every year, no matter what. We're considering the use of what the average use would be. So in a given average year, you're going to be using, we'd say 8 to 9 inches, which is significantly less than what you would need, for example, to get through a severe drought, where you might be using significantly more, upwards up into the 15, 16, 17, 18, even 18 inches of water in a given year. But this is sort of the metric that we would use for appropriating additional water, is the long-term average use, realizing that you're going to have periods of time where water use is going to be below that average. So then you would have increasing storage in the aquifer, but you're also going to have periods of time where you're going to have withdrawals above what that average is. And that's where you're going to be dipping into that storage reserves of your aquifer, with the idea is that you're not continuously dipping into the storage reserves of the aquifer. So this is presenting some water levels actually from that same hydrogeologic cross section I showed. And I chose this because it basically shows the response that you get from essentially two different types of aquifers. You saw that there was basically 2 to 3 aquifer intervals in there. The one where you see significant decline in recovery, that's the confined aquifer. And then the water levels you see where you're not seeing significant declines in recovery, those are from the unconfined aquifer. Also shown here are the hand measurements, so it shows you how much more information a real-time monitoring site is providing, as opposed to if we're just getting hand measurements, which was what was being done in the past. You'll also notice that the water levels in that lower aquifer are higher than water levels in the upper aquifer. However, during the irrigation season, they drop below that. So then those, as a result of that, that induces flow from the upper aquifer into the lower aquifer to offset the well discharge. So the declines you see in that upper aquifer could be in part due to 2 mechanisms. You have a mechanism where flows are being induced into that lower unit, but since it's shallow and confined aquifer, it's also subject to the natural evapotranspiration losses that you get associated with an unconfined aquifer. Additionally, when reviewing, we want to consider the soil, the water quality, and then I already touched on the aquifer properties. So the compatibility of the soil water quality with the soils, say for irrigation, for example. We also want to consider the sources of recharge and discharge into the aquifer. So direct recharge, that would be for your unconfined aquifer, where a rule of thumb, maybe 20% of your annual precipitation is as a result of infiltration into the aquifer. Large portion of that coming in the spring after frost dissipation, before evapotranspiration takes over. Leakage, as I touched on, is the sort of indirect recharge that occurs from water from a different hydrologic unit being induced into a different hydrologic unit. Additionally, surface water sources. So the Missouri River Aquifer here in Bismarck, obviously is affected by a surface water source. So if you put a well adjacent to the Missouri River and the Missouri River aquifer, that well discharge is going to be readily offset by potentially Missouri River water. Same goes for aquifers that are located along Lake Sakakawea. Hoffland Aquifer in Nesson Valley is a good example of that. The water levels in that are follow the lake levels. And then we're looking at discharge too. So shallow and confined aquifers like we have in the eastern and southeastern portions of the state, a significant amount of natural discharge occurs from either evapotranspiration or springs. So like your Elk Valley, your Page, your Cheyenne Delta aquifer, all those aquifers are located along the eastern side of the state. They're associated with deltaic deposits when rivers were flowing into the Glacier Lake Agassiz. There's beach escarpments there where you get natural discharge from the aquifers that occurs as springs. And then obviously another source of discharge would be the discharge from wells. So the way with which groundwater moves through aquifers and aquitars are dependent upon their aquifer properties. So here we're looking at hydraulic conductivity, which is a constant that relates the discharge rate to the gradient caused by water level changes. And then also specific storage, which is the ability of that aquitard material to release and then also store water. Now with aquifers, they're the same but different properties. Transmissivity, the ease with which water flows through that aquifer. If you have a high transmissivity, say for an irrigation well, you're going to see significantly less drawdown if you have a lower transmissive aquifer. Storativity, significant declines associated with confined aquifers as opposed to unconfined aquifers where the water is actually drained from the pore space itself. Now another thing that we can look at, and this is a result of the presence device, is that those are also recording barometric pressure. Barometric pressure affects water levels, and that is described as the barometric efficiency. So water quality, this would be a typical irrigation classification. This is taken from a permit I reviewed in the Douglas Aquifer. You can see it's pretty typical of water in an unconfined aquifer in North Dakota, where you're having a medium to high salinity hazard and low sodium hazard. So it is suitable, obviously, for irrigation. It's an unconfined aquifer, so the soils in that area are sandy. And barometric efficiency. So what I've got plotted here in graph A is the gray line is the relative water levels, and then the red line is the associated barometric pressure. Now, as you can see, as water levels go up, barometric pressure goes down. So there's obviously, you can infer some sort of relationship between that. So B and C, what I have there is BRF, which is called the barometric response function. The barometric response function is basically the time it takes for that barometric response, that change in barometric pressure to be felt by the aquifer. And you might be asking, who cares? So in an unconfined aquifer where it's readily attached to the atmosphere, you're going to have a barometric response function of around 0. So if you know little or no other information about the area at the time, you can quickly assess that that area is likely getting attached to the atmosphere, so it would be readily, it could readily receive recharge. Alternatively, if it's closer to 1, that means it's essentially detached from the atmosphere and it's not getting any sort of information or any sort of potential source of recharge. So examples of that would be West Fargo Aquifer, located in West Fargo. Also, Ray Aquifer, which I'll show in a subsequent slide. But the shape of that barometric response function, right there, you see it slowly creeping up to 0.4, then leveling off. That tells us that that area is subject to leakage. So we can verify that then by looking at an irrigation pumping schedule that we have for an irrigator in this area. This is an area in southern Divide County where we can generate an irrigation pumping schedule based upon the observed responses. We know what the irrigation, we know what the pumping rate of that well is, and then we can match it based upon what we concluded based upon that barometric response function, that it's likely a leaky aquifer. And then we can fit that to an analytic solution, and we can get aquifer properties. So the transmissivity of 10,500, a storativity that's reflective of a confined aquifer, and then also the hydraulic conductivity, which is that K prime, which is actually fairly high for a aqua charge, indicating that any sort of additional withdrawals are likely going to be offset by induced leakage. The other important piece of information is that we had limited test hole drilling up in that area. However, we were able to ascertain what the approximate width of that aquifer was based upon the response that we observed here. So as a result of this, then the permit under review, it was concluded that we could appropriate more water in this system. So our analysis on prior appropriation from groundwater systems, there's sort of two things that you're looking at. Short-term seasonal declines. How far is what sort of seasonal drawdown are we going to see? Is that seasonal drawdown going to be significant such that it impacts a nearby user? And then long-term trends too, which is essentially answering, okay, you're taking additional discharge, you're wanting to discharge additional water out of the aquifer. Where is that going to come from? It has to be offset from some other natural discharge area. Either you're reducing natural discharge to some area of the aquifer, or you're inducing some sort of you're inducing recharge. The inducing of recharge for like our leaky aquifers is by additional leakage. So our methods for analysis, I kind of touched on one here for that analysis of that Smoky Butte aquifer area. That was basically an analytical one where we looked at some of the aquifer properties, matched it to an analytic solution, and then was able to make predictions then on what additional drawdown there would be potentially from an additional well installation, and then also derive where the water was going to be coming from. It was going to be coming from water being induced into that aquifer via leakage. We can also use just simple observation where on occasion we have permits that are canceled and we have a period of record on it, and then an application comes in place of it. Well, if we already have a period of record of what the changes are to the water levels from a past application that was subsequently approved and then subsequently canceled, then we already know what the effects are. So the data sort of speaks for itself there. Now, as we get more and more users from a system, then we have to look at different maybe more robust methods. So we have what I'll call semi-analytic method, and then what a lot of people would hear about is numerical models, mod flow. So I'll cover those now a little bit. So this is analysis then on the impact of prior appropriators from that Douglas aquifer area that I was talking about earlier. This is what I would call a semi-analytic solution, where you have the mapped boundaries of this outwash plane, and then on the north side of it, north pointing up in this slide, I failed to put that in there. There's sloughs that are on the top on the north side of it, and then there's a slough that it all naturally discharges. There's a linear slough on the west side of it that it naturally discharges to, and there are a few irrigation wells in there that are taken into account. Those are the black dots, and then the proposed well is shown on the right-hand side of the screen, and along with the predicted drawdown. And that drawdown concluded it wasn't going to adversely impact any of the existing users in that system. And that 9.4 inches per year, what's being done there is it's kind of hard to see. You can see there's circles in there. And what that is I'm leveraging an analytic solution for circular recharge areas, and then averaging out that over the entire aquifer footprint. So that's equating out to about 20% of the annual precipitation in this area. So it's like 3 to 4 inches of recharge into that area. The reason for doing it that way is it's a much faster model. So it'll run instantaneously as opposed to a numerical model, which would take a longer period of time. Another thing to note from this too is that it's just reducing the amount of discharge flowing into that slough to the south and west. So essentially that's where the water is coming from. It's reduced the natural discharge to that slough to the southwest, on the southwest corner of the aquifer area. And I mentioned numerical models. This is a model that I did, I suppose it's already 9 or 10 years ago. This is of the Little Muddy Aquifer up in Williams County. Highway 50 and Highway 85, that intersection is known as 29 Mile Corner, 29 miles north of Williston, oddly enough. This was a model in response to a number of applications that we received both for industrial and irrigation in the area as well. And there's already a fair amount of irrigation that was actively taking place in that area. So in this case then, we did develop a full numerical model of this area. All those little grid points, those all have unique aquifer properties. And what I'm showing here is that 1909 on the left-hand side of your screen, this is basically assuming no development. And most of the discharge from this aquifer naturally discharges via evapotranspiration. And on the right-hand side, I'm looking at 1937, which was when we ran this simulation. This was the most amount of drawdown, and then most amount of drawdown that we saw throughout the historical simulation, which ran from 1900 all the way to well, it would have been about probably 2015. So that's the relative change in evapotranspiration. So you can see on the left-hand side, comparing the right-hand side, there are cells that are not colored anymore. Those are areas where the evapotranspiration has completely been offset by the pumping wells. And then there's areas of blue where essentially all of the evapotranspiration has been offset to satisfy the well discharge. And then the areas where you have yellow or even red, those are areas where that signal hasn't reached into that area yet to offset that evapotranspiration. So as you can see, in 1937, a significant portion of the area would have been depleted, and this area does provide base flow essentially to the Little Muddy River. However, this is just a snapshot from 1937, and it's not reflective of what it would be like long term. So long term, it's not depleting Little Muddy Aquifer. So the results of this was that we ended up approving an additional 1,500 acre feet of water as a result of this model. I did mention the Ray Aquifer. So the Ray Aquifer is that arm that you see on the right-hand side that naturally discharges into the Little Muddy Aquifer. That's why you have that area of significant evapotranspiration losses, because it is a shallow water table area in there. Now that Ray Aquifer, when it's recharged to the west of here, or to the east of here, and in that area, in the confined areas, it has a barometric response function reflective of it receiving water. However, when you get closer to the where it discharges to the Little Muddy Aquifer, it actually detaches from that confining layer. And then if you were to look at the barometric response function of that, it essentially is nearing 1, meaning that you're not getting any recharge in that area. And the only way that water is getting into that system is from the through flow from the areas of recharge near the to the west of the area. And that's all I have. So I'll be happy to answer any questions. If you have specific questions about your water permits, I do have all the staff here, so I'd encourage you to engage with them.
Okay, I'll hand the microphone around. Let's try to keep it to general questions for Andrew right now. And like you said, we'll hit the specific ones with the specific hydrologists that are here.
So what happens to those acres that are irrigated and then put into CRP? What happens to that permit?
So I guess I'm not aware of a specific permit that's getting put into CRP. If it would be non-use, it would be potentially subject to cancellation. Because my understanding would be they're essentially getting paid not to irrigate. I guess we could talk more if you're talking about a specific one. I'm not aware of it off the top of my head.
Other questions?
Yeah, I know I've visited with all of you folks various times about some of the things that we're doing in Dickey County and Dickey and Lamore County where we're tiling into a basin and want to water back out. And I understand that and appreciate all the things that you guys do. You're obviously studying from one end to the other. And I try to follow all the charts and things you put up here, but I probably should have went to 2 or 3 more years of college. But there's a lot of study that needs to go into some of these permits. There's some permits, like surface water ones, where we're tiling into a basin, want to water back out, probably wouldn't require as much study. Have you guys done any more talk amongst yourselves and how you do your policies and things like that to where we can possibly speed that process up for the quote-unquote low-hanging fruit? Because we've got some basins that are a pile of surface water goes in there. We're getting 2, 3, 4 inch rains, and overnight you got something that's come up, sometimes over a foot, and it's running over. It's going into a Dickey County drain number 1. I'm just thinking of one specific case, but yet we've had an application to water out of that thing, and it keeps filling up. It keeps overflowing. Have you guys done anything to do the studies of the low hanging fruit? The simple ones, they should be simple, that you could just approve and not spend a lot of time on. And, I've been to this conference for several years in a row now, and we've had the conversation multiple times. I'm just wondering if you guys have done anything to address that. From a farmer's perspective, it gets a little bit frustrating on our side because we're there every day and we see that thing overflowing and knowing that, gee, if I had a couple inches I could water in July and a couple in August or whatever, we would be adding a lot of bushels that would all turn into money that's spent in our local economies. So we get frustrated. We don't feel like we're being heard. And I'm just wondering if there's anything that you guys have done in your process that we can speed that up. Because to us, if the fruit was hanging any lower, you'd have to duck your head to get under the tree. But I understand you have a process, you have rules, you have policies, there's state statutes. Is there any way we can weave through all that and get some of these simpler ones done quicker? I hope that's good.
You're absolutely right, and that's exactly what we actually started this year. That's why we saw the significant increase in the amount of permit applications that were getting reviewed, and the surface water pending applications have essentially been chopped down to there's maybe a dozen or so, if that can be readily worked on. I know one thing I didn't touch on in part of the review process that we can't jump over is when you do have parties of record that are adamantly opposed to an application getting approved and requesting adjudicatives hearings. Then it has to go to an Office of Administrative Hearings. Then they have to schedule a hearing. Then we have to have the hearing. Then they have to issue a recommended order on it. And that's a process that as of right now we can't change.
Boy, have I ever gotten educated on that. There's someone with adamantly opposed to everything that goes on, whether we're putting water in, taking water out. It's unfortunate that the way the rules are set up, that some people can weaponize the process to slow it down immensely. And I know we're dealing with one situation now, and I just foresee another one coming in. Another one of the applications gets this far. But but let's just say that there isn't somebody adamantly opposed. Sounds like you're addressing that and getting someone involved in pushing some of these through a little quicker?
Yes. So, and then also more of a team approach too. So I don't have an assigned project area. I review every single action that comes out of the division, but I also was able to present some of the information, some of the applications that I reviewed. And I did that this year. So I reviewed a dozen or so applications. I wish it was more, but I got other stuff to do, I guess. But we have been looking at the low hanging fruit we have, and I was at the beginning of this year, I wanted 100 applications reviewed because I had realized that we had low hanging fruit, and there's no reason that if those permits that can be approved, there's no reason they shouldn't be approved then. I mean, I understand it's a matter of getting to it, but time is money for you guys.
Oh yeah, that's for sure. But and then also, I'd like to invite you folks that if you need more staff, you need more money for more staff, you want some people to help pay for some more presence systems put in. I know you only got one well drilling rig, but if there's more that we can do on our end, we invite you to let us know about it. And then the other thing is if you're in the area, stop on by. We'd love to show you some of the things we're doing. And I come here too to learn about, better ways to irrigate. And there's a whole lot of people in here that are trying to get better at it, because not only do we want to conserve that water because we are agriculturalists, we know that water's essential. Heck, it costs a lot of money. So, we got bankers breathing on our necks, trying to make sure that we're running our farm as efficiently as possible. And we'd love to show you guys some of the things that we're doing on a first-hand basis. So, I mean, you're always invited out, but if there's anything else that we can do to talk to our legislators to say, hey, these guys need a little bit more money for this. Maybe they need another well drilling rig. They need more people in research. But, don't be afraid to ask. And I sure do appreciate all the things that the North Dakota Irrigation Association is doing, and they're a great conduit between you guys and farmers too. But yeah, appreciate you coming in here and putting your feet in the fire just a little bit so you can hear from some of us. Sometimes we don't think we're being heard, but it's nice to have you here.
I guess I will say too, maybe I forgot, I didn't explicitly mention, I know drain tile water and the use of it for irrigation, as we have been readily approving temporary authorizations from that. We would have no intention of not approving those. The reason they're temporary authorizations is that drain tile water is essentially excess water that you're trying to remove from the landscape as quickly as possible. So capturing that excess water and then using it fits right in with the way that temporary water permits were designed to do. Another thing too is there was a mention of Rain 360, and we did issue temporary water permits for Rain 360s because we're interested, or I'm interested specifically too, in what sort of efficiencies are being gathered from those Rain 360s. So if we give authorizations to use those, then we can get in more information on those as well.
David Dahl, Southeast North Dakota. How fast does it take to get a permit through if you knew you were going to grant a groundwater permit? Like a year, 6 months? How fast could it go through your office, do you think?
So the average time, if you were to look from 2000, we'll go from 2000 to 2025. And I'm choosing 2000 through 2025 on permits that have been issued. And the reason for that is in 1999, we made changes to the application process, where the application process was completed when that comment hearing deadline was ended. And we have information on when that comment hearing deadline occurs. And we also have information on where that date issued occurs. So then the review time for that is the difference between those two. So average time, if you were to take all the permits issued, is from 2000 to now was 2 years. The median value is below that because there are review times that skewed that information. But alternatively, there is a fair number of ones that were reviewed in less than a year as well. So the minimum time, there has been permits in the past not recently, that were basically issued within a week after the comment hearing deadline. Those permits were water flooding permits where the source water is a non-potable aquifer source. So it's the Dakota aquifer where you have, they're taking water from the Dakota aquifer in western North Dakota and they're injecting it into oil producing formation for secondary recovery. So that Dakota aquifer is also the disposal zone for wastewater or for recovered water from oil production too. So there's more water essentially going into that aquifer than is what coming out. But why it's so easy to approve a permit like that is because there's essentially no prior appropriators on it, and it's not a potable source. It's not being used for it's being used for industrial use, but it's not being used for municipal, livestock, irrigation, any of these other uses.
The only reason I bring that up, we've waited about 19 years to get a permit. We finally got it. And it's brought a lot of economic benefit to the area, just in the, from the rural, the electric company, well drillers, the irrigation companies. And it seems like with all the data you have, this process should be extremely way faster. I'm not 100% sure that you guys make it too complicated to issue a permit. I mean, obviously I can't follow quite all that without way more training, but it seems like you should be way more efficient on this, or have be way more transparent with for instance, me or anybody that's got a permit available. It seems like unless we're breathing down your neck, you don't really say anything back to us. And then other things that I would like to see is, I'm sure you heard me earlier when I was talking to Steve here about if we're allowed 18 inches and I'm only using 3-4 a year, how come we can't double the acres and then only use half the water per acre? I know that's in Century Code, but can't you guys come up or help get some of this changed? And then my other question or comment is, how much do you guys put into technology or efficiency of irrigation to, we're using less water? I guess that's about what I got.
Yeah, and that use of less water would be reflected in that average use I was alluding to. So that use of less water, whether it be through efficiencies, increased precipitation, would be taken into account in an analysis like that. So, and to these areas that are more complex, things I've been looking at now is also that, okay, if we don't have a bandwidth to address some of these areas that have a significant number of pending applications and also significant numbers of use, can we go outside? So that was one of the benefits that I'm hoping that we get out of the numerical models we have. And if that's a successful model that we have, or an successful model basically for what comes out of the Elk Valley model, then there's no reason we probably couldn't replicate that for other areas to be more responsive. And then having the most important part of that too is that then we have a tool that's already built for the department that the department can then just use. And additionally, that's a tool for the department, but since it belongs to the department, then it belongs to anybody that wants to look at it as well.
Dean Schmidt here from southeastern North Dakota too. Kind of echoing these guys. I mean, I'm from that Oaks area. I mean, I think you guys have missed a whole generation of farmers because the water permits weren't issued, I'm just going to throw something out there. I mean, just off the wall. Is there any chance that we could get temporaries and let us do the drilling? Let us, and if it don't work, you study it. If you find that it's drawing too much, shut us off. We're out. But if we got land that we know has oodles of water underneath it, and we have to wait 20 years for a permit, why can't we, like I said, give us a temporary and let us drill and let us irrigate. And, you know, if it doesn't work, if you see something that's not right, well, then just shut us off and we're out. But I don't know. Like I said, I'm throwing it out there.
Yeah, and I know previously that the department has shied away from temporary water permits. I'm new, and I'm not necessarily opposed to the issuance of temporaries from areas where there's pending applications that they're not getting to. However, I would want to confirm that with the people I report to. But I do have thoughts that we could potentially, there would be cases and scenarios where issuance of temporary water permits, for example, people that are next in line in the area.
Because I know even what these guys are saying, I mean, come visit us. I mean, we can show you. I know you guys probably don't have time, but, you know, just come out and visit with us, you know.
Any other?
You hear me now? One more question. So with the advent of AI and everything going on, is that something that you guys study to help with all of the facets and all the different things that you study here? I mean, you guys cover a lot of stuff. Is AI something that you are harnessing a little bit to try and help the process? I mean, I'm trying to get my arms around it myself. My 85-year-old father can probably tell me more about it than I can. He's a techie, but how does AI affect what you guys are doing?
I've used AI to speed up code development.
Well, yeah. I mean, to any part of your process, has anybody studied? Can AI help you guys out? I'm just curious.
Well, I guess we're already starting to look at it. That's where I said we're using it for code development. So one of the nice things about it is if you can prompt it correctly, you can write. If you can prompt it correctly, I can get 300 lines of code written for me in a matter of minutes.
Huh.
If you prompt it correctly. If you don't prompt it correctly, it'll give you 300 lines of garbage.
So I think most of our questions come from southeast North Dakota, where we tend to have all of the problems with permits. Do you guys have, which I'm assuming you guys know, how many permits you have in deferred status, held in abeyance, denied, pending review since, I don't know, the 1970s? There's permits in our area that have not been issued since the 70s. So when he talks about missing generations of families making money off of land that they own, that is a very accurate statement. Because I know for a fact, I have been told by this department on multiple occasions that they will issue no more water permits in my area until we go through another 1988 drought. Well, I could be in my coffin 40 years before we go through another 1988 drought. If that's the theory that DWR has about issuing permits in my area, that is not an acceptable answer to anyone, because that's depending upon Mother Nature. We just watched a slideshow presentation this morning talking about how climate has changed and how our annual precipitation has gotten higher. Technology has changed in irrigation since my father started irrigating in the 70s. We were irrigating with overhead impacts. We were using, we can apply 18 inches of water. I just asked my dad, how many inches of water since 1976 have we used on average? He said it has gone down every year, and on the last few years, in the last 10 to 20 years, we have probably averaged 8 to 9 inches. We're permitted for 18 inches of water a year. And I have been told multiple times that I would like to irrigate a few more acres, not diverting the point of water from, it's coming from the same wells. But I can't do it because it's more acres. Not using any more water because I'm permitted for 18 inches. We're using 8 to 9, but I can't add more acres. So there's a lot of frustration from the farmer's side to the DWR because there's how many permits that are not being addressed. There, he talked about there's no communication. There's 0, 19 years. That's not an acceptable answer to have from a state agency, that 19 years, yeah, we're just going to leave them hanging in the air. We don't care. Ag economy has nothing to do with the state of North Dakota. I mean, the money that ag producers pay in taxes every year doesn't pay your job, correct? I'm sure it has nothing to do with funding any state employed jobs. That's a hard reality, folks. I believe we do. We're owed answers, and being held, have some accountability. We have accountabilities for what we do. We have to be responsible for what we do. But it doesn't seem like we send in a permit that there's any accountability from this department.
Well, I guess I don't know who said that. I don't share that sentiment that we'd have to wait to issue permits until 1988.
I have also heard that from some customers. I help them fill out permits around here, Bismarck, Tappan area. I have also heard that same exact sentiment of, because I'll, talk to the customer and I'll be like, call them and ask them what, just kind of probe, see what's going on. And that's been an answer I've heard numerous times, is we're waiting for another drought. And every time I'm like, I guess I don't really understand why, but I have also heard that before myself.
Well, I know in the Central Dakota Aquifer area, we have been actively issuing permits there in the past couple of years. So I can say in that area, additional permits have been issued.
But is there anything being done to address the permits that are deferred, that have been deferred since the 70s?
And that's where I go back to if the Elk Valley model aquifer, the Elk Valley modeling study we have right now, if that's one way that we can do it. The idea that no more permits can be issued from the Oaks unless we have a 88, I don't agree with. I would say that there are areas in the Oaks where we can issue more permits. There were 2 permits in the area that I wrote up this year because of their location. One was between the James River and what's the slough there, right along the border. And then there was another one right along the South Dakota border too, that they were not located any near area. That's another point I guess I can bring up, is that the idea of actively looking at applications that we have that may be in areas that are located at distances such that they're not going to impact, or they're not going to interact with any of the other existing users. Those are ones that can be readily approved as well.
I'll use myself as an example.
And I apologize, I don't know where your permits are off the top of my head.
So I'm from Milner, and so I'm out of a different aquifer than the Oaks area is, and a lot of different people. But so I have a permit that's been held in abeyance right behind my house. We hold all the permits that have been issued in that area, and they won't issue any more permits. I have a relative who's had one in since 1995. I have another relative that's had one in since 2012. They're either held in abeyance or they have been deferred. And I have brought this up multiple times that to the DWR, why don't we issue those permits? You know, I had said something along the lines of, well, let's issue the permit, you know, and have a, you know, first on, last off scenario. And I got told we can't do that because that's why the Ogallala Aquifer is in such deficit in Nebraska. Those were the exact words that I was told by this agency. And I'm like, well, I guarantee you right now that if you went to my relative and asked them if they wanted to put an irrigator in, they would tell you no, because it has been 30 years. He's retired now. So this, for a fact, I know you've missed the generation of an irrigation. That's 30 years of economic downturn that has been brought into our community. That's my frustration to try and convey to you guys to try and get something resolved. You know, what is the answer? And so when I talk about my area, I'm in a different aquifer than, like I said, everyone else. So who is that going to harm? And when they won't let me change anything, I'm the only guy on that aquifer. So I don't know why I can't get a temporary permit. Nothing. I've asked.
So there is an application that is being reviewed in the Milner Aquifer. I can give you in touch with the hydrologist after this, because I don't know if it's yours necessarily, but I know it's in the Milner channel.
Andrew, one other question Scott brought up earlier about the not using the full allotment of water that he has, and why can't I move that over to another acreage and use them excess inches of water? Is that policy, or is that century code where it states that you cannot? Because it's a question I get asked a lot in many different aquifers of using that water on new acreage.
So in rule, it's limited to 10% the originally approved.
In order to change that, that would have to be done legislatively. Okay.
It's an administrative rule. Yes. There's rules changes. Yes, you could. It still has to get. There's an administrative rule process. So.
Just one more comment on when we were waiting for that permit. They said, well, it'll be conditional. Well, obviously. And they said, do you want to spend that amount of money to maybe get shut off? Don't let that be on you. Let that be on us that want to build it. And they looked back and they said the only year you'd been shut off would have been 88. Well, I guess I'll take that chance, you know. And but don't let the price of it be put on you guys, because that should be put on us as wanting to build it.
Other questions?
Is that a thing? Like, are there live permits that have dried up?
We have had historic. We have had permits that have been shut off due to low water levels. Examples of that would be in the Streeter Aquifer. There were also orders that waters couldn't be withdrawn from the Souris River. It wasn't a groundwater source, but it was the Souris River in the 1980s. Low flow conditions also existed in the late 1980s as well. But as far as groundwater ones that I know, Streeter Aquifer from 1988 to 1991, there were approved permits that did not irrigate during that period of time.
Yeah. So you said back in the 90s, right?
It would have been
If I
88 to 91. So
Yeah. So
or
how
92
about like
potentially.
in the past, right? Give it the last 3-4 years. Have they dry? I mean, are these permits, are the water levels in these aquifers, are they only 2 or 4 feet above the casing, or do we got like 100 feet in a lot of the aquifers? Rule
So
of thumb, like just in general. Like how
it depends
tight
on where you are
these?
in the state. So eastern portion of the state where I was talking about unconfined aquifers, you're going to be less than 50 feet. Some of them are going to be upwards of 10 to 20 feet thick. As you go to Lake Service Plain area, that's also similar. That's also finer sand. The little muddy aquifer that I showed with the numerical model there, that has portions where the thickness of the sand and gravel in that area is over 100 feet. Hillsborough aquifer that we also encountered over 100 feet of sand and gravel too. That's actually one on the eastern side of the state, so that would be somewhat of an exception. There's also areas where it's predominantly shallow, but then there may be deep channels running through it. So there's an area, for example, in 2 areas that I can think of. Carlsruhe Aquifer, where you have the new Rockford Channel running underneath it, and then there's a portion where they're connected. So then that thickness of that aquifer basically goes from what would be associated with the Carlsruhe Aquifer, which would be, you know, tens of feet of thickness, but then where that new Rockford Channel underlies it, then your thickness basically triples. Also where Minot's Wellfield is, you have the Souris Valley aquifer that they're pulling from, but that's also intersects the underlying Sundre aquifer. So then that's a similar scenario where the thickness is significantly increasing just in that area where the Sundre underlies the Souris River aquifer.
So I've got a permit that I've been working with Sid on. He's been, you know, we got a little bit of traction here now this year, so I'm happy with that. And you guys installed a new test hole for us that they just put in, I guess it was only 2 weeks ago here. And looking at that, you know, so that's in the Strasburg aquifer. So that's like a 400,000 acre foot aquifer. And there's something like 1,700 permitted acre feet of use. So we're talking less than like 0.5% of utilization. And I forget exactly, but the graphs just came out. Sid had just emailed them to me. And we hit water like at 33 feet down. And we stopped drilling, I believe, at 200. You know, so we've got pretty major head pressure. You know, everything to me, just looking at it, seems like a no-brainer. So is there something, and not a no-brainer for staff, but farmer hat on, right? So is there something specifically that holds that process up, or is it just a matter of getting it through the system? What specifically gets looked at on something that's got that amount of utilization minimization, right?
Yeah, so that's where we get back to priority. And if I recall, there's something being looked at right there, but there's another application or point of diversion application being looked at right now. And then right after that, then your application would be reviewed, and we can touch base on where the review of those are after this as well.
I think it's important to understand too that all this information with these permits and when they established a date is all online. So anybody can look at it on the Department of Resource website. So you can go right to your aquifer and you can look and find priority dates and pull that up and you can see where you're at in line. Is that correct, Andrew?
Yeah.
I mean, I don't really have much to say, but we can pull up the priority dates. Yes, we can pull up the data, and just in layman's terms, we can look at the data, but it doesn't fix the process that kills this for 10 or 15 years, you know? So I'm 35, and I think what a lot of these gentlemen said is true. You push this off for 10 years or 20 years, who's interested anymore? You know? I'm not complaining, just like I agree with everything being said here, yeah.
Well, I guess I would respond with that the average time that I alluded to was about 2 years for issuance, and we are actively looking to issue all permits that can be reviewed. Yours is definitely one that can be reviewed.
And I'm not looking for a response, right? I think that's where it can get to be a lot of
Okay, just to clarify one thing, when I asked about moving the inches of water over to irrigate more acreage, that has to be fixed legislatively, not in-house. Jen? Jen's legal counsel for the DWR. So they want to take extra water that they're not using. They've been assigned a permit with 18 inches of water a year. They're not using it on average for the past how many years? It's 9 inches of water. Okay. And what the ask is okay, I'm not going to use that much. Can I take that extra 9 inches and move it over, use the same point of diversion, and irrigate more acres?
No, because there's an admin rule that says you cannot do that. Admin code is, so there's century code, which is what the legislature passes. And then there's administrative code, which is where the department gets into more details to implement the laws that the legislature passes. And the admin code also has to go to the legislature through the Administrative Rules Committee. So there's a whole kind of separate process for how administrative code is developed that does involve the legislature. It just also involves more of the department putting those technical details in there, because obviously the legislature doesn't have all the technical expertise of the department.
Does everybody understand?
So that's not what your permit covers, though. You applied for a specific acreage. I mean, also there's the difference. You're kind of getting into the difference between paper water and wet water. So you're applying for, you know, your average is the 18 inches, but that means sometimes it's less water than that, because like that's the most water you're going to put on there. And so that's the paper water, right? That doesn't mean that the actual water is going to be available. For a specific amount of acreage. So if you wanted to change that, you would need to come in for a new permit or an amendment to your permit. Okay. So then shouldn't that person also be entitled to use the water?
Correct, but I'm not going to subject myself to getting kicked out of using that water, because I will now lose my senior rights.
Oh. No, I'm not suggesting that. You would still retain your initial permit. You would just come in for another permit. So like you'd have two. One would be old, one would be new. Okay, other questions? Any other questions? So I think, yeah, if there's no other general questions, I think, Andrew, would you rather specific questions go to the specific hydrologist? Would that be?
Yeah, if they have specific questions on their permits, I'm probably not going to be able to get into the details of every single.
Okay. Does everybody know when they have specific questions for their hydrologist? It was up here, but do you know who your hydrologist is in your area? Okay. Any other questions for Andrew then? It's your time to speak. Okay. Then Andrew, your hydrologist will stick around here and they can just go up to him and ask him specific questions.
Yep. That's why I have them here. So, yeah.
Sounds good. All right. Thank you, Andrew. I appreciate it. Everything. Just a couple housekeeping details here. So I've been asked to announce that the resolution's final adoption is down in the Heart Room, beginning at 4. Social hour starts at 5:30. The awards banquet tonight is at 6:30. In your booklets, there's a survey. Please complete it if you would. It helps the gals out to plan for future. Okay, and any ideas you got, put them down. All right, let's give a round of applause for Andrew. Thank you.